now we start, how do you build proofs?
Click on it and you change the rule. Then you're also.
I can hear all the groaning going on in the class. Yes, logic is your origin of no pain, no gain. Greeks are pretty serious about that.
Definition. And then for that, you have to click on 12. Yeah, that is the
Everyone got your pictures? Can I cover it up? No? Save this as what? Proof what? There you go. How logical, right? Are you guys ready? Open up the next one. Okay, 6.3 next. So open it up from the Fitch exercise files. Do not, again, create it from nothing. It'll get you in trouble. All right, one for the last time. Since you guys got this down, but let's just repeat it. How do I set this up? So let's make sure that, let's see if that habit has been etched in your brains.
Put the numbers. One.
First time?
Oh.
First one, how do I set it up, everyone? No. First thing.
Oh, you like copy paste.
Huh?
Copy
So
and
copy
paste.
it,
Oh, copy and paste.
and then click up top. Get the pointer, and then? No.
Add after.
Add a step after, and then paste, and then show step numbers. The reason you got to keep doing the homework, you can't just sit there and absorb it, is because you're trying to etch down a habit of thought, a habit of self. All right, here we go. So here's the argument. It's valid. How do we prove it? This is where we're going to start. There's several algorithms, several recipes, several ways in which you can approach a proof. What I got on the first page is a series of basically strategies or algorithms, or call them what you want, heuristics, that's the fancier term, for how to break down proofs, yeah? The first thing we're going to try is the backwards method. The backwards method is all of steps 1 through 4 on that first page. So let's go through that bit by bit. Remember I told you logic is in part about learning to follow directions, right? But not to become a robot. It's a strengthening of the mind. Anyone here do martial arts? Or did some?
14 years already.
Okay, what are in fact, you find this across all martial arts. Whether it's karate, judo,
I do Aikido.
Aikido, sure. Forms of yoga, forms of Tai Chi, they're all sort of geared into an older tradition. We think martial arts is fighting. It's got an older, longer philosophical history to it. But the idea of, no, beyond self-defense, it's a way of, it's an aspect of self-cultivation. Sorry? It's a what? It's a way of, no, you're right, but way of what? I didn't hear. Beyond that, it's a way of being. So if you get to martial arts at its highest level, it's beyond fighting and all that. That's why it's called Do. Do is translation for Dao, way. These are all basically ways of being. If you get to the, so it's often said if you only focus on the martial, you become its beastly behavior. If you only focus on the way, you don't have the right structures to help you guide you on that path. Put the two together, and the true martial arts are basically ways in which you cultivate yourself using these techniques to help you realize a kind of higher order existence. Yeah. So what we got here, how does it relate to this? This is sort of the West's analog of a kind of martial arts of the mind, believe it or not. I'll talk about that parallel later on. But these strategies or heuristics or techniques for solving, they've kind of got like a structure to it. So if you do martial arts, like for instance in karate, they have katas, forms. You do those forms, the following the directions. You're not doing it to be like a machine going like this, right? You're actually using it to deploy self-defense mechanisms, right? Likewise here, if you follow it mechanically, initially that's okay, but what you're trying to do is break free of that to see the pattern behind it, okay? So here we go, step 1. Let's just read it through step by step. First one. No, step 1, backwards method.
Step 1?
Yeah.
Step 1.
In the backwards method, page 1 of the sheet. So everyone turn to the first page.
Look at the goals, goal, step, and identify the main goal.
Okay, right above that, look at goal, sub-goal, step. I want you to etch this in parentheses, because this is what it translates as. You guys ready? In your sheet. Right above, look at goal, sub-goal, put in parentheses, look at where your pointer's at. That's what this is saying. Look at where your pointer's at. So above, look at goal, sub-goal, slash sub-goal. Right, look at where your pointer's at. On step 1, backwards method, right above, look at goal slash sub-goal. Right, look at where your pointer's at. I've mentioned this before. Once again, has anyone heard the phrase, your attention determines your reality? No one? Huh? You feel enlightened? Good. All right, so right there, look at where your goal slash sub-goal is at. So Kenny, since you feel enlightened, you're up to bat. Where's your pointer at? Yeah, where what? Enlightened. Where's your pointer at? 2. And then it says, read on. It says, and look at goal slash sub-goal step, meaning look at where your pointer's at, and good. What's the main connective at 2? Good. And is the main connective. So every step builds on the previous steps. Now read on, Denny. Stop. Okay, so what intro? I click on rule here, but what intro? Since everything builds on the previous one, what did I identify as the main connective? What did Kenny identify as the main connective? No, that's not a connective. And there you go. So what am I guessing? What intro? And intro. Okay, and then read on. Michael? Yeah, you're laughing. You're up. And?
Add, fill in what the rule requires.
Parentheses?
Look up the
What does IE mean? You skipped it over, I know. What does it mean? Anyone?
Example.
No. Remember we talked about this? So one more time. I talked about it, but I said I'll cover it later. Here's the later. EG stands for? You guys are in college, so you guys will see this in the future, so you might as well know it. The contrast with this IE, they're not the same. What does IE stand for?
In other words.
You're right. In other words, the Latin for this is id s. That is id for that, or it is. No, you don't have to. I'll tell you what's right there, because I'll tell you how to translate that. So IE for your sakes, for your education, just means in other words, id s. Anyone here taking psychology? No one.
Nobody
The
translates
id,
social
Freud's
work.
ego, that's a mistranslation from Latin. The id, the it, the thing within you, the beast.
Yeah.
It stems from that. And they get translated over into English as the id. So it's not coincidental. So IE, just think, EG means I'm explaining something. Here's a concrete example to help you understand it further. IE says something different. IE says, I've said something, you don't quite get it. Let me explain it to you in other words, equivalent but in different terms. Okay? Make sense?
Yeah.
So IE, keep going, Michael.
Look up the format and the following page.
Okay, in that, right after that, everyone, after the period, look up the format in the following pages in that little space. Sketch this in. You guys ready? In that little space after, look up the format in the following pages, write the following. Flip the damn page. Or if you don't like that, you want some stronger, flip the effing page. You can write whatever you want on the sheet, whatever works for you. Flip the damn page.
After step 2, right?
Yeah, right there in that space. That's what, that IE, you ask Michael, what does that mean? Or,
Oh.
yeah, flip the damn page.
Oh, nice try.
When I took logic long ago, my teacher once said, logic is not a spectator sport. You can't just sit there and like osmosis and suck it in. You gotta actually do it. So flip the damn page. This is my mnemonic for you guys. So Marcus, flip the damn page. 2. What are you flipping to?
Rule.
2.
Next page.
And intro. Good. Remember, this first page is how to solve. Everything after is the library. You're gonna have this on the exam. So flip 2. And intro. What does it say? What did I tell you to write down? You need the ingredients above. So Kate, what are my ingredients here?
Your ingredients are
I'm right here. So this is the and.
so A equals C.
A equals C is one ingredient. So I have to actually etch it in. A equals C. And then B equals D. I go back down. When I get it to check out, it will not check out. The last thing you always need are the highlights or the boxes. Chow. When you look at and intro, what are the 2 things highlighted in the sheet? In your sheet. The 2 things highlighted are the E and Good, your ingredients. What are my P and Q here? What are my ingredients? A equals CN?
No.
Good. If I have these two ingredients, I can put them together to form that. I check it, I'm good. Okay? Then and only then when I get a check can I move up. I've broken the problem down to now getting each of these two. So I've just completed step 2. Read step 3 for Nico. Back to the first page, everyone. Step 3. Yeah.
I don't think it mattered though.
Until you have. Okay, this is what's called a recursive algorithm. All that blah, 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 blah. Here's what it basically says. It says you're taking some complex and you're working backwards, breaking down the things until you can't break it down anymore. This is sometimes called, has anyone heard of reverse engineering?
Yes.
Some of you know. Okay. It's a powerful notion. It's applied in engineering today. It has older roots in logic. Let me use a quick example. You got a car, right? It's a hybrid.
Prius.
No, it's better than that. It gets 100 miles per gallon. Yeah, 100 miles per gallon. 100 miles. So they got some engineers. They look at it. And they're like, how did they do that? So what do? They buy one of these things, and what do? They take it apart. The reverse part is you like lay it out bit by bit. So you see them like on a mat, right? And every piece is carefully laid out. That's the first part. The reverse engineering is break it apart, see what the components are, until you can't break it down anymore. Then the second part, so that's sometimes called analysis. You break it down. The next part is synthesis. You want to know how each part functionally relates to the other parts, bit by bit by bit, until you integrate it into a larger whole to see how the overall whole functions. This principle is there in not just engineering, but ecology as well. Simple systems, more complex systems, how do they interact, how do they break down as far as they can. Kind of make sense? So the backwards method is basically that kind of reverse engineering. So here we go. I'm going to keep breaking it down. So I got to apply the algorithm to 2 and 3 until I can't break them down more. Since I got to do both anyway, let's just move it up to 3. And then say so I keep working on this, and then I go back to step 1. So you cycle back to step 1. Jeanette, read step 1?
Look at goals, sub-goals.
Basically look at where your pointer's at, right? And
identify the name.
okay, what are my connectives? Forget what I have up there. What are the 3 connectives so far? And, or, and. You remember? No. And, or, and. There's only 3 Boolean connectives we got. And not. Not is the other connective. Equals, strictly speaking, is not a connective, but you can kind of, this is where it gets a little bit sort of messy, right? Equals is not a connective, but they treat it sort of like a connective, okay? So this is basically simple. The idea is, can you break this down anymore? Can you just say B or D? No, this is a atomic unit, right? When I say B equals D, that thought, B is equivalent to D, cannot be broken down any further. So this is basically what I mean by a simple piece. It's an atomic, you can't break it down anymore. So this loop continues until you can't break it down anymore, in which case you're out of the loop and you're on to step 4. So Christine, read step 4.
Look at your assumptions.
Yeah, hold on. Yeah, read it. Not you.
Look at your assumptions above, then work top down. You're supposed to.
Okay, good. Under top down, in your sheet, in scare quotes, under top down, I want you to write the following in your sheet. Under top down, write, in parentheses, write guess, sum, elim, rule.
Yes.
Guess, sum, elim, rule. Under top down, write guess, sum, elim, rule.
Just make a guess.
Educated guess.
Sure. Oh, okay.
Yeah.
Guess something.
Not a random guess.
Oh.
Right. That will work. It might, but yeah. Question. There is no or.
He was saying what could it be? But there's no or, so it's
Okay.
Oh, so it's and.
yes.
I'm not sure what you're talking about.
Yeah.
What?
All right, let's continue on. So let's just, and then you'll hopefully get it bit by bit. Okay, so this is simple. So I'm out of the loop. So this is basically I'm working top down. Top down means literally you work from the stuff you have above, and you try to find a way to connect it up to these components. In fact, if you look at 2 as well, 2 is what? Rachel. Is 2 complex? Yeah, is it complex? Are the connectors? No, so it's simple too, right? So 2 and 3 are both simple. What's the only thing I have above to work with? What number? 1 is it, right? So let me create some space above and use 1 working top down to then try to get 4 and 5. Okay, so I'm going to use 1. What's my main connective there, Josh? And when is and true?
Only when both sides.
In this case, how many sides are there?
3.
How many ands are there?
2.
Yeah, so how many pieces are there?
Oh, 3.
Yeah, 3. So, but same logic, right? So, what I'm working top down, Janelle. So I'm guessing some kind of.
Say that again.
I'm working top down, so I'm guessing some kind of.
Left.
And what's the main connector for 1?
And
And so you should guess that, but then always look it up. So look up Andy Lim. What does it say, Tati? When you look in your sheet, what does it say for Andy Lim? Good. You break either side. In this case, I got 3 sides, right? So let's start breaking them down. Give me one piece. Give me one of the sides from 1. A equals B. That works. I check it. I'm good. I then break down the next component. What am I going to do there, Patricia? So what's the other next component to break down from 1?
Same as?
What's the middle piece?
Oh, equals?
Yeah, what is it?
Oh,
B,
B and C
equals.
equals C and D.
No, B and C equals C is the middle component. That's the next
B
thing I
and
can
C.
break down. Sarah, what rule is that says I can break off either side of the end? Andy Lim. I just broke down the middle part. And then Colton, finish it up. What's the last piece? C equals D. What rule is that? And what do I have to highlight? Because if I just do it like that, it's not easy to check. Because that's where it comes from, right? So I verify it. Elim again is extraction. Can I break down 1 anymore? No, I've already broken it down to its component parts, right? 1, 2, 3, and 4. So that's all I can do with 1. I've sucked out or extracted or eliminated all the information I can. I've got to now use 2, 3, and 4 to work my way down to 5 and 6. Let's do 5 first. So 5, Hikaru, I want A equals C. Where do you see A connecting up with C up here? So if A equals B, and B equals C, put them together to get? A equals B, then B equals C, put them together to get? A connects to B, B connects to C. So what connects to what? A equals C, is that right? What rule is that, Mariah? You remember this old rule?
And it's show?
No, it's not and because there's no and there. Old rule, not in the sheet. What's the rule for sub? Oh, good. Anacon, not there. The other one. The other one. Anacon's like the all-time cheating rule, so you can't really use it at all. What was substitution? Not Andy Lim, but? Keep going. Because equals, the idea here is I'm substituting it, right? A equals B, B equals C. I substituted for B with C to get A equals C. All right, that's the only time you're going to see equals 11, pretty much not at all. So there it is. Equals 11. And now 6, what do I have access to, Domingo? What numbers?
Yeah, everything about.
Everything about 5, 4, 3, 2, 1. Where do you see B and D connecting up?
B and D.
So B equals C. If B equals C connected up with?
C equals D.
To get? B equals D. What rule is that, Nicole? Equals 11 because I'm substituting it again. Welcome to your first proof. Yay! Copy it down carefully. Whew.
6.3.
We got one more to try, but we're not going to complete it. We're going to start it.
6:12 already, Kyle. You already know the time, though.
No, we're not.
It's 6:12 already.
It's not 6:12.
No, it is. It is 6:12.
Your watch says 6:12. It's not 6:12. Oh, you're right. It's 6:13.
I just, I was part of the teachers out of that.
I
Who
didn't
cares?
see
I don't
that
care
yet.
if we go overtime. Let's just do that. So.
No, we're not gonna do it all. We're just gonna start it. I'm gonna take you down a dead end, and then I'm gonna correct it next time because the dead end will help out.
Wait, I need a picture.
Yeah, today, unfortunately, today and Thursday, we're gonna pretty much go almost to the end, if not past. We got a lot to cover. But this is the foundation for all future proofs to come. Everyone got it? No? Everyone got the picture? Okay, if you need it later, we'll do it. Let's open 6-5, start it, and then I'll let you guys go free.
So this is going to be due next Tuesday.
Yeah, I'll talk about that too. Remind because I know people will try to turn stuff in. All right, 6-5. Yeah. 6.5.
Alright, Kyle, let's do this.
Yeah.
Okay, what I'm gonna do is take you down a dead end, but this is a good instructive dead end. Let's use the backwards method. So I called on who's up? Corey. So Corey.
What up, yo?
Actually, we didn't cover this yet, but yeah, let's do this. Backwards method. Step 1. Read it. Step 1. First page.
Step 1. Well, look at where your pointers are at. So
And
yeah, look at those. So those.
same thing, right? Identify
the
the
main connective.
What's the main connective here? So this is where your pointer's at. What's the main connective?
Should be the and somewhere. Yeah.
No. What's outside of parentheses?
Or?
Yeah, or.
Okay.
And then step 2, James. Oh, sorry, Ambessa. Then guess.
You guessed the intro.
Okay, what intro? What did I just identify as the main connective?
So it would be an or intro.
Or intro. What do you do after you guess or intro? Unless, yeah, Alyssa?
You need one of the sides.
You turn the page. Everyone, turn the page. When I say action, like you literally turn the page. You. So turn the page, and what does or intro say?
You need one of the sides of the or of the
Okay, what are your sides?
A and B.
And?
Or A and
Which
B.
side do you want? You don't know which one. It's like you get a fork in the road. You're allergic to proofs, I understand.
A or B.
You want A and B? Okay, sure. We don't know. Let's try it out. So A and B. So I go back down, I highlight this, I check it out, it's good, okay? Anytime you get the check, then you move up, and then you repeat it. So you go back to step 1. Everyone, let's do this all together. Everyone, what's the main connective? And. So step 2, what do I guess? Everyone. And step 2, guess? Guess? Step 2, guess? Look at it. Step 2. Guess intro. So what intro?
And intro.
And intro. What do you do after you guess the rule? Okay. How colorful. Fine. I should have said you can write that down. So what does and intro say when you look at it? Good. What are the ingredients? And A is one ingredient. B is the other ingredient, right? And then now, what do I highlight for and intro to get this to check out? B? The ingredients, 2 and 3. So if I have 2 and 3, I can get that, put it together to form 4. So far, so good, right? Now the question is, can I break these down? Well, let's look at 2 first, because I see A above. What's the main connective in 1? This is simple, by the way, right? So when I go to step 1, it's simple. That means I skip to step 4. I'll repeat that next time. But I'm on step 4. Anytime it's simple, you're working top down. I see it in 1. What's the main connective for 1? When is and true? When both are true. So if you know A and B or C, does it have to follow that A is true? Yes. What rule says you can break off either side of the and? And lim. So that works out. Now the question is, can I get B out of this? Well, where do I see B? In 1. So break off the other side to get? No, break off the other side of 1 to get? B. Or C, that's the other side. What rule says I can break off the other side of the and? Andy-lim, because that's what Andy-lim says. Now the question is, I got all this to check out. I have 1x. from this, can I get B from B or C? Think about it. B or C is true. When is or true? At least one's true. Do I know for sure B is true? No, since I don't know for sure, can I ever get from that B for sure?
No.
This is a dead end. You could back your way out, and then you could say, okay, initially I guessed A and B for my OR. I try the other route, A and C, but you're going to end up with the same problem. So there's an advanced move to be made that I'll teach you